In the silent, unending darkness beyond our solar system, a lone traveler, a small spacecraft, is still faithfully sending signals back to its home on Earth. That spacecraft is Voyager 1. It is a relic of a bygone era, a testament to human ingenuity, now sailing through the cosmic ocean far from any star. Launched in the late summer of 1977, Voyager 1 has become the farthest human-made object ever created. It has journeyed across billions of kilometers of empty space, a distance so vast it is almost impossible to comprehend. For decades, it has been our silent emissary, exploring regions of space no probe has ever reached before, dutifully reporting its findings across the void. But recently, after more than 40 years of predictable, reliable operation, something strange happened. The steady stream of data, the spacecraft's only voice, began to speak in a language its creators could not understand. Voyager began sending garbled information about its orientation in space. Its attitude. The numbers and signals coming from the spacecraft did not match what engineers expected. It was as if the probe was suddenly lost, unable to report its own direction, even as its main antenna remained perfectly pointed at Earth. At first, researchers at NASA's Jet Propulsion Laboratory believed it might simply be a technical glitch, a symptom of old age. But the deeper scientists looked into the data, the more mysterious the situation became. The anomaly was isolated and bizarrely specific, and the rest of the spacecraft seemed perfectly healthy. The puzzle was only just beginning. To understand why this is so unusual, we first need to rewind the clock and understand the Voyager mission itself. It was a mission born from a rare celestial alignment, a grand tour of the outer solar system that was only possible once every 176 years. Voyager 1, along with its twin, Voyager 2, was launched by NASA in 1977 with a bold mission to explore the gas giants of our solar system. Using gravity assists to slingshot from one planet to the next, the probes embarked on an unprecedented journey. Voyager 1's primary targets were Jupiter and Saturn, and the data it sent back revolutionized our understanding of these giant worlds. At Jupiter, it revealed a world of unimaginable complexity. It studied the churning planet-sized storms of the Great Red Spot and discovered that Jupiter's moon, Io, was the most volcanically active body in the solar system, spewing sulfur hundreds of kilometers into space. It gave us our first detailed look at Europa, an icy moon whose cracked surface hinted at a vast liquid water ocean beneath, a potential habitat for life. After Jupiter, Voyager 1 raced toward Saturn. There, it unveiled the breathtaking intricacy of its ring system, discovering they were composed of thousands of individual ringlets. It found tiny shepherd moons like Prometheus and Pandora, whose gravity sculpts the edges of the rings, and it made a close flyby of Titan, Saturn's largest moon, revealing a thick, nitrogen-rich atmosphere denser than Earth's. But once this spectacular primary mission ended, Voyager did not stop traveling. Instead, its trajectory flung it upwards, out of the plane of the planets, and it continued moving farther away from the Sun. It was now on a new, even more ambitious journey, the Voyager interstellar mission, heading toward the very edge of our solar system. For years it traveled through the vast outer bubble of the Sun's influence, known as the heliosphere. This is the region dominated by the solar wind, a constant stream of charged particles flowing from the Sun. In 2012, after crossing the turbulent boundary known as the termination shock and traversing the chaotic heliosheath, Voyager 1 achieved something historic. It became the first spacecraft ever to enter interstellar space. Voyager crossed a definitive invisible boundary known as the heliopause. This is the point where the outward pressure of the solar wind is no longer strong enough to push back the wind from other stars. It is the true edge of our solar system's influence. Beyond this point, Voyager was no longer exploring our solar system. It was a true interstellar probe, sailing on the galactic winds and exploring the galaxy itself. It was now in an environment fundamentally different from anything it had experienced before. And it was here, in this strange new region of space, that scientists began noticing something unusual in its transmissions. The spacecraft's Attitude and Articulation Control Subsystem, or AACS, which controls its orientation, began sending back what appeared to be gibberish. The telemetry data appeared corrupted. The AACS was reporting random, nonsensical values, suggesting the spacecraft was tumbling wildly. Yet, the signal strength remained strong and steady, which meant the high-gain antenna was still locked perfectly onto Earth. The two facts were in direct contradiction. At first, engineers suspected that Voyager's aging computer systems might be failing. After all, the spacecraft was designed with 1970s technology and has survived extreme radiation, freezing temperatures, and the harsh environment of deep space for over 4 decades. A component failure seemed not only possible, but probable. However, something about the problem did not quite fit that explanation. The team ran diagnostics and found no evidence of a hardware failure. If the AACS computer had truly failed, it should have triggered a fault protection routine, putting the spacecraft into a safe mode. But that never happened. The spacecraft was still communicating clearly with Earth. Its other instruments, like the cosmic ray subsystem and the plasma wave subsystem, were still collecting valuable, uncorrupted scientific data, and its core systems were still functioning surprisingly well, powered by the faint warmth of their decaying plutonium core. So, what was causing these strange signals? If the hardware was fine and the spacecraft wasn't actually tumbling, where was this phantom data coming from? Scientists began to consider that the answer might not be inside the spacecraft at all. The problem might not be a malfunction, but a feature of the environment it was flying through. Instead, it might be something in the interstellar medium around Voyager. The probe was now a sensor, not just for what its instruments were designed to measure, but for the very nature of space itself. Interstellar space is not completely empty. It is a tenuous sea of charged particles, tangled magnetic fields, and extremely energetic cosmic radiation. These invisible forces can interact with a spacecraft's sensitive electronics and sometimes produce unexpected readings, especially on a vehicle with as little shielding as Voyager. One possibility is that Voyager has entered a region of space where magnetic fields behave differently than expected. The galaxy's magnetic field is not uniform. It can have kinks, folds, and regions of magnetic reconnection where field lines explosively realign. Such an event could create a burst of energy that might affect the spacecraft's sensors and create strange patterns in the data being transmitted back to Earth. Another theory suggests that Voyager may have passed through an area filled with extremely hot, dense plasma. Even though space is mostly a vacuum, there are clouds of energized particles that can reach temperatures of tens of thousands of degrees. Flying through one of these previously undetected pockets, or shock fronts, could create an electrical charge on the spacecraft's surface, interfering with its sensitive electronics. But there is also a more intriguing, and perhaps more likely, possibility. After months of investigation, the engineering team traced the problem to a single, subtle point of failure. It turned out the AACS was routing its telemetry through a defunct onboard computer, one that had been dormant for years. This dead computer was corrupting the data before it was sent to the telemetry unit. The spacecraft wasn't lost. Its messages were simply being garbled by a broken translator. The fix was simple. Command the AACS to send its data through the correct, functioning computer, and it worked. But this doesn't solve the deeper mystery. What caused the computer to suddenly switch its routing? The leading theory is that a high-energy cosmic ray, a stray particle from a distant supernova, struck the spacecraft's memory chip in just the right place to flip a single bit of data, causing the routing error. In other words, Voyager may have been hit by a ghost from a dead star, triggering the anomaly. It was a reminder that it is traveling through an environment humanity has never directly observed before. Despite the strange signals and the ongoing risks, Voyager 1 continues to operate. Its systems are stable, and its science instruments are once again sending back clear data. Even after more than 4 decades in the harshness of space, it is still sending vital information back to Earth from over 24 billion kilometers away, a lonely outpost of humanity in the great cosmic dark. Each message from the spacecraft, traveling at the speed of light, takes more than 22 hours to reach us. A command sent from Earth will take another 22 hours to arrive. A simple conversation with our most distant explorer takes nearly 2 full days, and every precious signal it sends, every packet of data, helps scientists learn more about the mysterious, uncharted region between the stars. It is our only direct measurement of this frontier. For now, the strange data from Voyager has been resolved, but it remains a profound puzzle and a warning. The incident highlights the incredible fragility and resilience of this aging probe, but the spacecraft continues its journey into the unknown, traveling farther and farther away from our solar system every single second, at a speed of over 60,000 kilometers per hour. Its power is fading, and within a few years, its instruments will fall silent one by one. But even after it goes dark, its journey will not end. Somewhere in the darkness of interstellar space, Voyager will continue to drift silently for millions of years, a time capsule from Earth carrying the sounds and images of our world on its golden record. The mystery of its strange signals is a reminder that we are exploring a universe that is still largely unknown. And, whatever Voyager discovers next, in the time it has left, could change our understanding of that universe forever.